And welcome to Otten Math. In this edition of Otten Math, we're going to accomplish solving three problems using special right triangles. Okay, the first one, number 25, we want to find the length of segment DC, this entire length here, and BC, this length here. We're given DA is 4, we're given that angle C is 45 degrees, and we're given that angle A is 60 degrees. All right, so what we want to do is we want to draw two altitudes, one from D to AB and one from B to CD, and as we create these right angles, we're creating our special right triangles, a 30, 60, 90 triangle and a 45, 45, 90 triangle. So as we do that, we see that in this case we have the hypotenuse, we have this length here, which is the altitude, and then also the length here. And let's just identify these points. I'm going to call this E, and I'll call this point F. Well, I can figure out the length of AE because I know it's the side opposite 30 degrees. It's going to be 2, and then therefore DE is going to be 2 root 3. Well, if AB is 2, then I know that EB has to be equal to 2 because AB is 4, so 4 minus 2, EB is equal to 2. Now, if EB is equal to 2, I've just drawn a rectangle here, so DF has to be equal to 2. I have a 45, 45, 90 triangle. In this case, if this is 2, I also know that this length FB is going to be 2 root 3 because the both DF and EB are parallel, so the distance between DE and FB are going to be the same. I have two altitudes drawn from two parallel lines. So both FB and DE are the same distance, so I know FB is going to be 2 root 3. If FB is 2 root 3, then FC has to be 2 root 3. And I know that CB is going to be FC or FB times root 2 based on my special right triangles information. So CB is going to be 2 root 6. So DC then becomes 2 plus 2 root 3, and BC becomes just 2 root 6. Okay, moving on. If the area of a rectangle ABCE is 8 times that of triangle BCD, so the area of this entire rectangle is 8 times BCD, how far is D from the origin? Well, we have to figure out where D is. Well, we know that I have a rectangle here, so there is no difference here in the x value between E and A. So the x coordinate stays the same, and the y coordinate is going to move to 0 because I'm along the x-axis. Same here for C. Now I'm moving up 5 units on the y-axis, but my x value stays the same. Right, so let's see what we can determine from this. So I have negative 4, 0 as my coordinate for A. I figure out that C has a coordinate of 16, 5. Now I need to figure out what D is going to be. Well, I know that ABCE is going to be 20, which is the length from E to C, or 20 units times 5 length from C to B. It's going to be 100 square units. Well, I know that DBC is going to be 1/8 of that, so triangle DBC is 12.5 square units. And I know that half base times height is equal to the area of the triangle DBC. I know that the height is 5, so 1/2 5 times, let's say, the base DC is equal to 12.5, and I figure out that the length DC is 5. So given the length of DC is 5, and I'll let you, if you want to pause because I'm going too quickly, just go ahead and pause, then I know that the coordinate for D is going to be 11. This is not a decimal, it's 11, 5. The y coordinate stays the same, the y coordinate stays the same, and the x coordinate shifts to the left 5 units. All right, so if 11, 5 is the coordinate, now I can figure out the distance from the origin to D. I simply use the distance formula. 11 minus 0 squared plus 5 minus 0 squared is equal to the square root of 146, and that is my answer. All right, last set of questions. A bag contains 8 triangles, 5 are members of the 3, 4, 5 family, 2 are 30, 60, 90 triangles, and the last does not belong to any family. If 2 triangles randomly fall on the floor, what is the probability that both are members of the 3, 4, 5 family? At least one is a member of the 3, 4, 5 family, and then one is a member of the 3, 4 family, and one is a 30, 60, 90 triangle. So the first question is both are members of the 3, 4, 5 family. And all I need to do here is multiply. In this case, I create my tree. There is a 5/8 possibility that the first triangle is a member of the 3, 4, 5 family, because 5 out of the 8 triangles are 3, 4, 5 family members. And then the possibility that I draw another 3, 4, 5 family is going to be 4 out of 7, because I have 7 triangles left. I've taken out 1. I have 4 out of 7. So I'm going to multiply those two values together. I get 20 over 28, or 5 over 14. For B, B is at least one is a member of the 3, 4, 5 family. And what I want to do in this case is I want to say, well, what happens if none of the members are part of the 3, 4 family, 4, 5 family? What is the probability that that will happen? And so I say to myself, okay, well, I can't have anything part of the left-hand side branch, and then portions of both the middle and the right branch cannot happen. So I want to figure out the probability that I have just the x value, which is the no family triangle, plus the 30, 60, 90 triangle, and then the 30, 60, 90 triangle plus the no family member triangle, and then the 30, 60, 90 triangle. So I'm going to take 1, which is a probability that I'll select 2 triangles, and that has to happen, minus the probability that I will select the no family member triangle, x here 1/8, and then a 30, 60, 90 triangle times 2/7, so I have 1/8 times 2/7, plus I choose a 30, 60, 90 triangle, then a no family member triangle, which is 2/8 times 1/7, so 2/8 times 1/7, minus I choose a 30, 60, 90 triangle, and then another 30, 60, 90 triangle, so 2 out of 8, and then I eliminate one possibility, so I have just 1 of the 30, 60, 90 triangles left. So it's 2 over 8 times 1 over 7. I know I'm going through this quickly. So I end up subtracting from 1, 656, and I end up with 50, 56, or 25 over 28 is the possibility that at least one of the members is going to be a 3, 4 family, 3, 4, 5 family. So again, what I do is I figure out what's the possibility that I don't select any members of the 3, 4, 5 family, and I subtract that from 1 to get my result. All right, the final question says 1 is a 30, 60, 90 triangle. I'm sorry, 1 is a member of the 3, 4, 5, and then 1 is a 30, 60, 90 triangle. So 1 member of the 3, 4, 5 triangle, and then 1 of the 30, 60, 90 triangle. So my first possibility is I draw a 3, 4, 5 family triangle, and then a 30, 60, 90 triangle. And then the second possibility is I draw a 30, 60, 90 triangle, which is going to be 2 out of 8. 2 out of 8. And then I draw a 3, 4, 5 triangle, which is going to be 5/7. And then I add those two together. So I have 5/8 times 2/7 plus 2/8 times 5/7. And that leaves me with 1056 plus 1056, which is equal to 20 over 56. And then I reduce that by a factor of 4, and I get 5 over 14 is the possibility that I'll draw at least 1 3, 4, 5 and 1 30, 60, 90 triangle. So here I set up the tree. I figured out the possibilities of the tree, first 3, 4, 5, then 3, 4, 5, 3, 4, 5, then X, 3, 4, 5, 30, 60, 90 triangle, and so on and so forth. And I can use this probability tree to figure out the answers to each of those individual questions.